My name is Lawrence Moroney. I'm a developer advocate here at Google. I'm taking a big risk of doing a talk with a brand new Linux laptop. So I've been having some tech challenges here on the podium, particularly with screen resolution. So bear with me if any of the demos go a little bit awry. So I'm a developer advocate here at Google. I focus on a technology called Google Play Services primarily. And Google Play Services, if you're not, actually, who's familiar with Google Play Services? Okay, most of you, so then I don't need to go into too much detail on it, but basically it's a way that we have of shipping the runtime for various Google backend APIs. And it's something that we update like roughly every 6 weeks so that we not go in like Android release cycles. We can go much faster than the typical Android release cycles, and we ship via the Play Store, that kind of thing. So I've been a developer advocate at Google for about 2 years. Prior to that, I did a lot of mobile development, freelance mobile development, including quite a few mapping apps on the iOS platform and on the Windows Phone platform. And it was an interesting experience. And what I'm trying to bring today is like having used Google Maps through Google Play Services and having built various mapping applications, I wanted to come up with like a set of tips for various things that you may not realize that will really, really improve the perf of your maps. And as perf matters is the theme of the show, hopefully some of these will be useful to you. I'm an author. I've authored 20-ish, I've lost count, of computer programming books, primarily on the Microsoft platform, but forgive me for that. And about 2 years ago, I got into writing novels, and this is shameless self-plug of my newest one, which is coming out next month. And I'm the host of a show called Coffee with a Googler on the Google Developers channel. Anybody watch that? Nice, thank you, thank you. So that's basically where what I like to do is just grab a Googler, sit down, have a coffee with them, and talk about what they do, why they do it, how they do it, and just try and like lift a little bit of the veil that's around Google, so that you guys can see like we're just normal guys, normal developers like you. We love this technology, and that's why we do what we do. So. The agenda today is just really talking about location-aware applications and like looking at some of these 10 tips around building better apps. Build better apps is a mantra that Magnus, if you're familiar with him, and I came up with, that really why we do what we like to do is that we really want to help you guys build better apps. It's very easy to build mobile applications. It's very hard to build really good mobile applications, and it's a journey, towards making them trying to improve them in any way you can. And no matter how good your app is, I think there's always ways to improve it. And we're always here to learn from you, just as hopefully you can learn from us. And with some of these 10 tips, some of them may apply to you, some of them may not, so your mileage may vary. Okay, tip number 1, and this one actually blew my mind when I started trying to think of some of the new things. And number 1 is like with Android Studio, if you've refreshed it and brought it up to date, there's a new Google Maps activity template that ships in Android Studio. And for me, I've been building maps with Google Maps for Android for like a year, 2 years. And I got to the stage where I always bypassed the wizard, and I just rolled my own maps. And I'll roll my own apps that use maps. And if you do that, you may remember that you got to go to the developers console, you got to register your app, you got to remember the namespace for your Android app, you got to turn on the APIs, you got to get an API key for that. Oh, sorry, I forgot. You got to get the SHA-1 key for your development machine first, right? And then you got to go back. And there's all these ugly steps that you got to go through, and all these hoops that you got to go through just to get an API key so that you can build a mapping app. And it's like, it's not necessary. It's a lot of friction, particularly for new developers. But it's one thing that we've really improved, I believe, in the new Android Studio. And the idea is like if you use the maps template, you get an XML file. It's called like mapactivity.xml or something like that. And it looks a little bit like this. And if you can see in the comment at the top there's a URL. And that URL is generated dynamically for you based on your app. And it remembers the namespace, it gets the SHA-1 key, all that kind of stuff. You paste that URL into your browser, you get your API key back, you paste your API key into that, and you're done. So all those ugly hoops that I was talking about, all that, all that stuff that gave people like me a job, teaching you how to do it, is now gone. And I taught a course. Who's familiar with Udacity? You guys, anybody use Udacity? Oh wow, a lot of you. It's really cool. I love Udacity, and I've done a Maps course on Udacity, and the Maps course had 3 modules in it, and like most of the first module is teaching you how to jump through all those hoops. So it's a lot of time that I had to spend recording it, but more importantly, it's a lot of time that you guys have to spend watching it in order to like figure out how to jump through these hoops. But thankfully, this new template that ships with Android Studio takes all of that complexity away from you. and gets you quicker at producing maps. And when I'm talking about perf, I'm not just talking about runtime perf, I'm talking about developer perf as well, your own performance. And hopefully this will get you into using maps a lot more quickly, a lot more easily, and a lot more friendly so that you can focus on what you're doing. Okay, tip number 2 is to think about light mode maps. Now, it's all very easy to put a map into your application, but I've seen applications. I'll give one example. It was for a sports complex near where I live, and they had this application, and they asked me to, how can they make this application faster? Some of their users have been complaining about it. And they had a map in the application which was directions to where they are, and that's all the map did. But they had the full map in there with all of the controls and all the panning and zooming and all that kind of stuff, and they used the full control, and it took them time to develop for that, when most of the functionality that gives you for all that extra weight, they never used. So it's a common mistake that developers make because they're not aware of light mode maps. And we have light mode maps now. It shipped a few months back with, for Google Maps. And if you follow this URI, it'll you can learn about it. But the idea is that you trade off a little bit of the interaction in favor of having a much lighter map within your application. And some of the things that are available to you, sorry, I can't see my slides because of my screen issues, so I have to keep turning back just for 1 sec. Some of the things that are available to you is going back to the sports app, this sports complex app that I was talking about. One thing that they really wanted to do was, okay, well, if you can touch on the map, then can it navigate from where you are now to get to us? If you want to come skating with us, how do you get there? So guess what? Light maps will actually give that. You can launch an activity, and you can launch a view or directions request from that. So you don't lose that by going to light maps. All the different types, normal, satellite, hybrid, all that kind of stuff are still available within light maps. If you like to draw on your map, maybe draw a circle around the area that you cover, or draw polylines for whatever you would draw, maybe a territory that you cover as well, these are still also available. Projection is still included in API maps, and by that what I mean is that's calculating the latitude and longitude offset based on the pixels on the map itself rather than just the pixels on the screen. Location is supported, so if you're using location on your phone, you can still plot the location on the map. It has partial marker support. This is one of the trade-offs. If you build an application where you want people to be able to drag markers around, drop them in different places, and customize them at runtime, light mode is not for you. But if you just want to plot markers on a map which are static, then you don't have to trade that off if you're going to use light mode maps. And same partial camera support. There's some nice little applications. If you watch my Udacity course, you probably saw where I built one application where you could fly from Dublin to Tokyo in about 2 minutes. Wouldn't that be really nice? Or from Tokyo to Dublin and back. And it was this beautiful panning that the camera can do around the Earth, showing the Earth flying underneath you, all that kind of stuff. Unfortunately, you can't do that type of thing with light maps. You'd still need to have the full Google Maps experience to be able to take advantage of that. But if you're thinking about your application, if you're thinking about, you just need a basic map in your application that maybe has some polylines, maybe has some markers, but you still need to maybe launch out to navigation, light mode maps will work for you, and it's much, much lighter, and it'll perform a lot better within your app. Okay, so tip number 3 is to consider GeoJSON or KML. Now, anybody using either of these at the moment? Nobody. Okay. So for some types of applications, and I'm going to demo one in a moment, I have an application, hopefully I can get it to work on this screen, which plots all of the earthquakes that happened on planet Earth in the last 24 hours. And what happened is the US government, the USGS, has provided a feed in GeoJSON of basically those earthquakes, including the latitude and longitude, the magnitude of the earthquake, and all that type of thing. And because they have formatted their data in GeoJSON, the task that I have as a developer to actually build a map to plot that is insanely easy. Now consider that if you're building an application that maybe needs to plot a lot of pins on a map, how would you do that? You might have your server that's generating these pins dynamically, and you've probably rolled your own data format in order to download that. And then on the mobile phone, you have to write your own parser to parse that and to plot them. And we're all smart developers. That's something that we can all do. But have we optimized that the first time we've built it? Have we optimized the data transfer the very first time we've done it? Have we optimized the client for consuming that and plotting those pins the very first time we've done it? The answer is probably no. And the answer is we may have a lot of work to do to actually build a client to be able to plot these. But if on your server side you encode these in GeoJSON, and it's a really straightforward format, And then on your client side, if you use, there's a set of utility libraries, they will decode the GeoJSON on your behalf and plot it for you. And I'll show a quick demo of an application that does that. And then I'll show you how much code on the client side was required to do this. So bear with me while I change out of presenter mode on the side screen. Whoops. And see if I can drag the demo over. Wi-Fi in here has not been behaving for me, so it might take a while for the pins to appear. And I can't really drag any further than that, can I? There we go. So I'm just running this in the emulator. It's hitting the services at the moment to download the pins. There we go. Now the pins are beginning to appear. So this is a very simple application. I got my map. I got my standard controls on my map. I can zoom into my map. I see these pins. These pins are colored based on the earthquake magnitude. So we can see like a green pin here was a magnitude of 1.69 earthquake. And this blue pin was a magnitude of less than 1. So the amount of lines of code to actually do this, where it's about 2 lines of code to consume the GeoJSON and to plot it on a map. I'll show that code in a second. But as you can see, typical map, lots of pins, very, very easy to develop. Now the URL, this is one of those Linux laptops with a really large screen resolution, but the second screen is not so big, and we get something like this. So if I go to the URL, it should be here. Or if you want to open this URL yourself, you can see a little bit of what GeoJSON looks like. If my, again, Wi-Fi here is not really behaving. I'll give that a second. Oh, you know what? I'll come back to it. But it gives you the idea. And here's what the code looks like. When I had my GeoJSON URL, oh, it actually loaded. When I moved it away, I'll take it in a second. So when I have a GeoJSON URL and I download the GeoJSON data into a JSON object from that, all I have to do is create, if I'm using the Android map utils libraries, all I have to do is create a new GeoJSON layer and then add that layer to my map. And that's it. Right? I didn't have to write any code for parsing out the data. I didn't have to write any code for plotting the pins. And the people who've written this code haven't written it as a V1. It's an open source library. You can see all the changes, and it's continually being optimized. So performance of productivity, if nothing else, it's great. But I would say also argue for performance of, like, if you need to plot a lot of pins on your map, and these pins are something that your app you need to generate server-side. Like one application that I wrote when I was freelancing was, it was for hotel chains. And each of these hotel chains had a curated set of things near their hotel that they wanted guests to be interested in. And that was a set of pins. It was a set of latitudes and longitudes and a little bit of metadata about the location. They had a server that would spit that out. And this iPhone application that I had written, I had to write a custom parser to parse that data, to plot it, to pin it, all that kind of thing. I wish back then I had known about GeoJSON. And let me drag my GeoJSON over. I gotta get this out of full screen first. And you can see a little bit what GeoJSON looks like in the browser. It's pretty straightforward JSON code. So this is the code that was generated by the US government's earthquake service. And you can see it's, you know, you have JSON where you just say it's like, it's been generated, there's a time that was updated, but ultimately there's a latitude and there's a longitude and there's metadata about the event. And all I did, load a JSON object with this code, create a GeoJSON layer, add the GeoJSON layer to the map, and I was done in creating that mobile application that we saw earlier that was plotting these pins. I think it's pretty cool. Okay. In addition to that, sorry, let me go back. So that was the code for using GeoJSON. In addition to that, there's also KML. It's very similar context, but KML is usually used for drawing like outlines on a map. So for example, you may have seen maps that show the Googleplex, and it has outlines of the actual buildings in the Googleplex, and when you go down to them, then you have different floors, and you can see like what's on different floors, and maybe you see that in shopping malls is a great one on a Google Maps. The language KML is a markup language that's used to define that. And again, if on your server side, you need to generate some type of dynamic floor or outlines on a map, why not generate it as KML and very similar kind of thing here, 2 lines of code to be able to apply that to your map, instead of you thinking in terms of all the polylines and all the floors and all those kind of things that you would have to do. It makes your life a little bit easier. Okay, tip number 4, cluster is not necessarily a bad word. So this is a map. Anybody guess what city this is? I guess you can read it on it. There's a train station. This is the city of Cardiff in Wales. And this is where I went to university, and I'm getting to go back there next week. I'm really excited. It's one of my favorite cities in the world. And when I was there as a student, there was a Chinese restaurant. I was a poor, broke student, and there was a Chinese restaurant with a really cheap lunch that I absolutely loved. And it was almost every day I went there as a student. So I went onto I won't say which website, I went onto a website to start looking to see if I could find this Chinese restaurant. And I did a search for Chinese restaurants in Cardiff, and I found 3. And then I went onto one of them and I asked to plot it on a map, and I got this. All right, can you spot the Chinese restaurant on this map? And Cardiff is a wonderful city with lots of restaurants, but I can almost guarantee not every one of those dots is a Chinese restaurant. There's all kinds of things there. There were sandwich bars. There's if you've got sharp eyes, the dot over on the rightmost one is actually in a prison. And and no joke, it's actually apparently it's one of the best restaurants in the city. I'm going to go visit it, and what it is, it's for rehabilitating the prisoners. They give them jobs as chefs and as, waiters and all that kind of stuff, and people say it's one of the best restaurants in the city. I discovered it when I was, looking for something that, something completely different. But anyway, so the problem with a map like this one, and when I took this screenshot, I was using a really cheap Chromebook. When I was searching for this, it's like a $100 Chromebook. And when I have a map like this, I can only see a limited part of the city, and I've got all these dots on this map. And if I pan this map around, there's several hundred dots here. They have to pan around as well. If I zoom in and out, the map has to plot where these are. And as you can imagine, that can be very, very slow, particularly on a really cheap Chromebook. And my experience in using this was very, very poor. But clustering, and here's another example of when you can cluster pins together so that the map is smart enough that it determines that if there's over a certain number of pins in a specific location, instead of plotting all of those pins, it will gather those pins together and plot one entity instead. And if you look at this is a map of London, and if you look here, I believe there's over 1,000 items actually plotted on this map. You can see there's 4 200s, there's 100, there's a couple of 50s, and there's 1,070 items actually being plotted on this map, but the number of things being drawn on the map is it 9? Yeah, there's 9 items. So if I zoom this map around, I'm only moving 9 items. And if I zoom in, then it will replot this. I mean, I can show a live demo later if anybody wants to see it. I'm having troubles with this screen, so I won't show it now. But if you've seen clusters before, if you zoom in, then it will pick the location that you're in, and it will intelligently cluster them. But the idea behind that, first of all, a great user experience, but second of all, performance. Because as the user pans, as the user zooms around, you're only moving 8, 9, 10 entities instead of 1,000 entities, which I would be moving if I tried to pan this map without clustering. So clustering, not a bad word, it's a good thing. I'll skip over the demo for the time being, and I'll show the code. Again, the code is really, really simple. If you're reading your clusters in, so we provide an object in the utils library called a cluster manager, and you create a cluster manager for your map. As you can see here, I have cluster manager is new cluster manager of item, and just this.getMap. And then I have cluster items. And if I store my locations as a cluster item, if I store my, I have a collection of my locations. If I create a cluster item from that location and then add those cluster items to the cluster manager and then render the map, all of that hard work of managing the clusters, of drawing, is it 200 in this area, is it 100, is it 50, of panning and moving them around, all of that work is done for me by the mapping engine. So again, it's, like I said, this is something you could roll yourself, and you'd roll a V1, but it would be optimized. I'm sure there's some great developers here who could build something awesome, but it may not be optimized at V1. This is stuff that we've been working on for some time, and this will make your maps faster, and it will greatly improve your user experience. Now, they may not discover a restaurant in a prison the way I did, but at least you'll be able to really, really polish and make your mapping apps a lot more slick when using this. Okay, next one is consider something called polyline encoding. So one of the apps that I wrote when I was freelancing was for a company that provides services for pet owners. And in some of the major cities like New York City, there's a big business of hiring people to walk your dog, right, while you're at work. But if I hire somebody to walk my dog while I'm at work, how do I know they actually walked my dog? And so part of this application, I couldn't put a beacon on the dog, maybe someday that would be good, but part of this application was that, part of the service was that your dog walker would then run this application while they're walking the dog. You would ask them to walk in a particular location, and then it would plot, you know, a little bit like you've probably all seen apps for like managing if you go for a run or if you go for a bike ride, and you can plot that. Same kind of thing, and it would plot the dog walk, and it would plot when the dog walk happened, and you could even plot when you paused for a little while you were walking the dog, and you can figure out why you pause for a little while you're walking a dog. And you know, all this type of thing was very valuable to the subscriber, because now they could see that this money they paid to a dog walker, the dog really was being walked. Now, when you map a route like that, you generate a lot of data. And I'll give one data here. This isn't a dog walk, this is a bike ride. This is a bike ride that my wife and I did about 3 weeks ago. And we did this 26-mile bike ride on the east side of Seattle. And I took a look at the data dump for this bike ride, and there was 3,008 data points were collected when I did this bike ride. So the data points that were collected were like, you know, the longitude, latitude, the time, the speed I was going at, the elevation, all that type of thing. And the service that, you know, provides these data points would give me an XML dump, and I downloaded that XML dump, and I took a look at it, and it was 1.3 megabytes of data. That's a lot of data. Now, to be fair on this service, they have a lot more data than just latitude and longitude. You know, when I'm drawing the line, all I want is latitude and longitude. So a lot of that data is also, a lot of that size is because of really useful data like speed and elevation, and that type of thing. But when I take a look at if I want to just draw a line, like in my dog walker scenario, I did a polyline encoding of my latitude and longitude data from this plot. On my 26-mile bike ride, 3,008 data points, when using polyline encoding was about 30K. Okay, that's a lot less than 1.3 megabytes, right? And so if you're building an application that does something like my dog walker or plots anything on a map and you need to store that data, consider polyline encoding. I'm not going to go into the algorithm now. It's quite an involved algorithm, but it basically turns the latitude and longitude numbers into, it string encodes them, ASCII encodes them, and it takes about 8 to 10 bytes per latitude-longitude pair to be able to do that. And that's where I came with like 30K for 3,000 odd points. I'm just rounding it to 10 bytes per one. The URL here, sorry if it's hard to see, but I'm sure the slides will be shared. We do actually have on the Google Maps website, the polyline encoding algorithm is there. But guess what? You don't need to write it yourself because we've written it for you. So if you want to get a set of data and you want to polyline encode it, you can do so. So on your server, for example, you could polyline encode something like this, so it's 30K instead of 1.3 megabytes. And then on your client, you're going to download that 30K string, and the libraries will decode that for you into a set of points that you can then plot on a map like this. So again, great perf improvements. You don't need to write all this for yourself. You don't need to store all this type of data for yourself, and just use the libraries that are out there. And again, as I've been saying, they're optimized for you. So here's my favorite map again. And tip 6 is really around curated locations. So one of the things that I found that provides great value in, I spoke a little bit, I created a mapping or hotels app that had mapping in it. And one of the things that was of great value to our customers, the hotels, was that instead of a blind API call to something like a Places API that just throws like a bunch of places at the user that have been generated by Google's algorithm, it was much better for the customer experience for something curated. So the concierge of the restaurant, the concierge of the hotel has tried this restaurant and loved it. We want to tell that to our customers. He's been to this museum and it was awesome. We want to tell that to our customers. So there's a dichotomy between having a pure, just curated set of content or having something that's API driven so you can take advantage of the universe of information that Google APIs can give to you. Well, there's also a happy medium in between them. And this happy medium is go ahead, build your curated content, store it in a local database so it's fast, the user doesn't need to be connected or anything like that. But guess what? These locations, when you use the Places API, have an ID. So why not just store that ID in your local database as well and get the best of both worlds? So now you're looking at, for example, I'll go to my hotel scenario, best 10 restaurants within a mile of the hotel. The hotel has picked these. The hotel might have a relationship with these that'll give you a coupon or have pictures that they've taken of these restaurants. But for the user experience, you can also use the Places ID to call the Places API and to get back information that Google provides about that place, such as reviews, such as a street view so you can see what the restaurant looks like, such as the online menu and everything that will be available in Google Reviews. So a great way to really optimize your maps or location experience for your users is to curate, and use the Places API smartly. This map of my future visit to Cardiff was an example where the Places API really wasn't used that smartly. It was like, this guy's looking for a Chinese restaurant. Let's plot everything that's associated with food within a 2-mile radius of his hotel. And this really doesn't help me because there's no way I'm going to click on every one of those dots to check out that restaurant. Okay? I ended up finding the prison one that I've been joking about just because it was off by itself on the right-hand side. Okay, location and sensor optimization is our next one. Now, if you're using location services on your phone, guess what? It can eat your battery. With Android, we have this thing called a Fuse Location Provider that allows you to pick different levels of location access. You know, the topmost level is like you're using the GPS, you're using the radio, you're using a Wi-Fi signal, you're using lots of other sensors to be able to determine location. But of course, the more accurate, the more expensive it can be on battery life. So you really be careful and really optimize how you're using your location services. First of all, you don't always need to turn them on startup. One thing that we've noticed when working with apps and when looking at apps a lot of the time is, as soon as the app opens, boom, I need to use location. And there's one app that I've used for when I ride my bike, and that's what it gave me. And I'm like, I'm in my garage pumping up the tires of my bike right now, and I open the app, why do you need my location now? How often are you going to be pinging the GPS to be able to get my location now? It might be 20 minutes before I actually start riding. So think about, as you're building for location, starting at the appropriate time. With activity recognition on your phone, you can get really smart about that. You don't even need to, you'll ping the user for permission to use location services, and in Android M, we do that at the point that the location service has been accessed, rather than when the app is first installed. But once you've done that, you can start using something like activity recognition to say, okay, Lawrence is now riding his bike. Let's start pinging for location services. It doesn't always have to be at startup, and it's a common mistake that we see. Secondly, a lot of times for a good user experience, you turn on your location services, you open a map, and then you wait. And you wait for like a few seconds maybe, or maybe a little bit longer for it to actually plot where you are right now. There's a little used and really cool get last known location on the location API. And what that will do is that the last known location that you're at, it may not always be right, it may not always be where you are now, particularly if you travel a lot. It's kind of funny where it's, I might open an app that's using get last location, and I live in Seattle, and it'll show me I'm in Seattle until location initializes properly, and then say, actually, you're in Dallas. So it doesn't always work great, but in some scenarios, it works really well to just get your user into using the location, into seeing where they are, and then maybe, for example, seeing restaurants or whatever around them very quickly. And it's something that's really worth investigating for great user experience. Maintaining a best estimate is also something that's really good. When you receive location updates from the Fuse Location Provider, there can be random noise in there. You've probably seen some applications where it's showing you a bike ride, and you're going and you're like this, and then there's one point over here, and then you're back and like this and like this and like this again. And like what that application is doing is that's just receiving updates and plotting them without really thinking about them, without doing anything smart. There's good things in there for maintaining a best estimate. We've provided some code. It's on the Google developer site for smartly maintaining a best estimate like that. I'd strongly recommend to go and take a look at it. And then secondly, to adjust the Fuse Location Provider as needed. I mentioned before there are different tiers of the Fuse Location Provider, and you can change them on the fly. And again, if you're concerned about if you're building an application that needs to plot your GPS location every few seconds, like for a bike ride, it's pretty obvious you need to keep it on the highest level. But maybe you're not building an application that does that. Maybe you're building an application, for example, that says find the nearest coffee shops near you. you turn on the fuse location provider to the highest level, you find out where you are, and then you turn it right off again, or you turn it down, that type of thing. It's a really, really powerful tool, but like any powerful tool, you have to use it wisely. So remember, the higher the sensitivity, the higher the cost, and your users don't like it if you spend their battery life flippantly. A bad habit that people do is to use overlays to segregate data. And you've got to be really, really careful when using overlays. So for example, in the earthquakes example that I showed earlier on, there were different colored pins for different magnitude of earthquake. And there's an argument for you to put each of these on a different layer, so then from the user experience point of view, you could say, okay, turn off the layer of low magnitude earthquakes so I can just see the high magnitude ones, or turn off the, vice versa, that type of thing. So the user has this really nice experience, and it's very easy for you to develop because, turning layers on and off is very, very simple. But you've got to be really, really careful when using layers and overlays like this, because if you think about there's, say, 20 different types of earthquake magnitude, and I now have 20 different layers, and I'm using a low-powered device, if I start dragging my map around, I'm replotting 20 different layers, and each of those pins on each of those layers has to have its relative coordinates plotted based on its latitude and longitude, and perf can be killed as a result. So my recommendation would be, unless you absolutely have to use layers, avoid using too many of them. Great examples of layers you probably see in Google Maps, like traffic is a good layer. So like I like when I'm using Google Maps that I don't see traffic until I ask for it. And then I turn on the traffic layer, and if I'm dragging my map around to see my location, say from here to the airport, then I understand that I'm getting a perf hit because of all this extra data, but I've asked for this extra data. So I definitely recommend that when you're using overlays, just be very, very careful about using them. Design your application sensibly so that the number of overlays that you're using is really based on what the user needs. And don't forget to give your users the option, of course, like in the case of the traffic one, to turn overlays on and off. Okay, tip 9, using beacons. And the demo gods haven't really been with me today, so I can't really demo this. But how many of you have used beacons? Oh, wow, a lot of you. Cool. So beacons, I find are a lot of fun. I have a few Estimote beacons up here on stage with me. And one of the things, though, with beacons is that sometimes a lot of the samples that I've seen with beacons and a lot of the methodologies I've seen with beacons are unnecessarily complicated. And they can be quite difficult for the user as well as for the developer. Let me give an example. I've seen a scenario where beacons could be used at a bus stop. So you put a beacon like this on a bus stop, and you write an application for your phone so that when your application is open and it's sniffing for the beacons, and it gets the ID of this beacon, and then it knows which bus stop that you're at, and it will give you a bus schedule for buses at that bus stop. Great, right? Anybody see the drawback? Trick question. What's that? I wasn't thinking of that one, but yeah, that is a good one. And the sticky on this isn't very good. They keep falling off. But more it's a case of this broadcasts a unique namespace and ID anyway. So why do I need to register? I can just sniff that namespace and ID at any point, and I can build an application that's based on sniffing that namespace and ID. And in Google, a few weeks back, we actually ran a competition for people to build applications based on beacons. And for the competition, I won a prize in the competition. I came up with the idea of virtualizing these beacons. So instead of thinking of a beacon in terms of absolute sense, like this beacon is at this particular bus stop and needing to register and having that kind of thing, there are scenarios where you want beacons anywhere to be used to be able to do something. Now that sounds very vague, so let me give an example. What I wrote was a game. My game was a virtual tour around some locations. So I had these 3 locations. I work in Google Kirkland. I had these 3 beacons around Google Kirkland, and I knew the ID of these beacons. And I built a little server-side application that said, the beacon with this ID is in the barista cafe. The beacon with this ID is in, I can't remember what it was in, like registration. And the beacon with this ID is like in such and such a meeting room. And then when somebody played the game, the idea of the game was that there's this like animated character who talks to you through cyberspace. I have a picture of her here. There's a bunch of videos, these CGI videos that are on YouTube of her talking to you, and she's guiding you and you're saying, can you go to this location? And then the location is what's printed at the bottom. In this case, it was Building B Barista. And then you got to go there and play a game. And then she tells you to go to the next one, and you go there and play a game. But the idea is then by virtualizing the beacons, anybody could take any set of 3 beacons anywhere, maybe bus stop beacons or maybe beacons around the conference center here, and turn that into the same game. You didn't have to be playing it in Google Kirkland. And that's the concept that I'm talking about when I say to virtualize beacons. It's really, really powerful. Another great example, if you're building for customers, would be, for example, department stores. So there are Macy's, there's one just across the road here in the mall, there's one near where I live. You know, big department stores like Macy's, instead of you registering a particular beacon in a particular Macy's location somewhere, you could say, the beacon of this ID is in the menswear in Macy's in Texas, in Dallas. Another one is in the menswear in Bellevue in Washington, that type of thing. So then when you use location services to say, oh, this user is in Washington, he or she is in Bellevue, and let's start sniffing the beacons that we can see. I've matched this beacon against the menswear, and now I'm able to give an experience for menswear in Macy's, that type of thing. So virtualizing beacons can actually be really, really powerful. I'm going to open source that game if anybody wants to email me if you want to take a look at it. It's a whole lot of fun. I hired a professional actress to voice this character. It's really cool. I'll see if I can run it on my phone in a moment, but the Wi-Fi hasn't been behaving. So tip 10 we're on to next is a lot of the tips that I've been talking about today actually are part of this. We have a thing called the API utility library. If you build anything to do with maps, I strongly recommend you go and download this today, download the samples for this today, dissect this today, because a lot of the tips that I've been going through have been encapsulated in APIs that are in this. So GeoJSON and KML that I spoke about are available in this, so your decoders for Android are in there. Heat maps is something I haven't spoken about, but if you want to plot a heat map around a particular area, like, you know, thunderstorms. I hear the thunderstorms coming tonight. So if you wanted, instead of just plotting pins for thunderstorms based on the concentration of thunderstorms in a particular area, to actually build a heat map, which would give the user a better, or the earthquakes is another one, to give the user a better feeling of what, you know, is really happening with the data. Heat maps are great. You can customize your markers instead of just the usual regular pins. You can customize them and have a whole lot of fun with them. The clusters, which is probably my single favorite feature. If you've ever built any map applications, clusters are really your friend. You know, all that cluster manager stuff is in there. The Polyline encoding that I spoke about, so the libraries to turn latitude and longitude into a few bytes so that you can store, decode them, make your life a lot easier is in there. Things such as calculating distance between 2 points. You know, it's not really a straight line because of the curvature of the Earth. The things like that, those type of distance calculations are in there. Area of a location, same thing when you think about curvature of the Earth as well as contours. That's in there, heading calculations in there, and it's all open source. And there's a really teeny tiny URL there, sorry about that. Hopefully when the slides are shared, you'll be able to see them. But wait, there's more. In good, what's the word? Good commercial sense. Anyway, so what are those late night commercials? What are they called? Infomercials, thank you. In good infomercial sense. Wait, there's more. So there's lots of other great stuff with maps that I didn't have time to fit in. Maps on Android Wear is something that we shipped. So you can actually have a little map on your watch, great for navigation applications, that type of thing. And there's something called ambient mode, which turns it down into a low contrast map, a very dark one when you're not moving your watch around to save battery life. The camera, to play with the camera is really interesting to create very dramatic scenarios. There are 3D plots you may have seen on Google Maps, and when you combine those 3D plots with satellite imagery, you can create really interesting, fun, beautiful fly-arounds of cities. And again, they perform really, really well. Street View, also known in my opinion as best tech ever. Okay, so Street View was the tech that made me fall in love with Google. And I tell this story all the time, and this is a true story. And earlier on at the beginning of the presentation, I said I write books. And I wrote this book back in 2011. And it was a science fiction book, most of which was based in the Navajo Reservation in New Mexico. And some of which was based in a small town in Japan, just outside of Nagasaki. And after the book was published, within the same week, coincidentally enough, I received 2 emails from readers. One from the town in New Mexico that the book is based, is called Shiprock, and one from Omera in Japan. And they said, "We love the book. It's so cool that our town was in this book. This is fabulous. When did you visit? You know, when did you write this book? If you ever come back, you know, let's grab a coffee together or something like that. This is fabulous." And I was like, I've never been to either of those towns, and I did everything using Street View. You know, I opened up Street View and I walked around the town, and like one of the scenes in this book is in the high school in Shiprock, and apparently I nailed it. You know what it looks like, and I was like, I've never even been. I'd love to go someday, but it was all thanks to Street View. That's why I love Street View, to me, aka best tech ever. And think about the things that you can do for your users by having Street View in your apps. Marker visualizations, custom markers I've mentioned already, sorry. Another one is geofencing. Anybody build anything or familiar with geofencing? Oh, cool. Nice. So geofencing is the idea is you can pick a latitude and longitude, you can define a radius around that, and generate an alarm when something enters or exits that area. And I used to have this app that I used at home, and my family still use it, so that, you know, when my daughter started driving, we asked that she use this app so that just we could know where she is. But one of the downsides of this app was that whenever she came home and went through the geofence for home, a sound would play on everybody's phone. Now, my dog got to associate this sound with my daughter coming home, and my dog loves my daughter to bits. So he would hear the sound on the phone, and he'd go crazy. Right, you know, because he would go run to the garage and like bang, 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 bang on the door so we could open the garage so he could go out and he could greet my daughter coming home. And so one day as an experiment, I decided to get the WAV file of the same sound and play it. Poor dog went nuts. You know, my daughter wasn't home. I opened the garage. He had to run out to the garage. He had to run around the garage, that kind of thing. And it took a little while for him to be satisfied that she wasn't actually there. At that point, I was tempted to play the sound again, but I'm not that cruel. You know, but it's just, so some of the scenarios that can be enabled by geofencing, I just think are really, really cool. You can trick your dog with it, or you can build applications that are good for families or whatever using geofencing. And one thing that I actually built once was a virtual reality game that used geofencing. So once you ran into a particular area, then you have augmented reality in that area. And then you had to do things within augmented reality. It was a whole lot of fun. And then finally, the activity recognition that I mentioned. You know, the activity recognition APIs, they will give you back a percentage likelihood that you're doing something. They're not entirely 100% accurate. They will say, hey, at this moment in time, there's a 20% chance that you're running, but you're probably standing still, that type of thing. So, you know, it takes a little bit of working with them and a little bit of intelligence to be able to use them very, very accurately, but they are pretty good. Okay, so contact my Twitters. I'm at L Moroney. If you have any questions for me, it's lmoroney@Google. On Plus, I'm Plus Lawrence Moroney, or Facebook, it's facebook.com/Lawrence.Moroney. So with that, thank you. Sorry for the few technical hiccups that we had, and if anybody has any questions.